Let's take a look at Project 2, Lesson 8. Each lap in the Indy 500 is 2.5 miles. A driver completes 2 laps in 1.5 minutes. The average speed during the second lap is 8 miles per hour faster than the average speed during the first lap. Find the driver's average speed for each of the 2 laps to the nearest mile per hour. Okay, we have a lot of information to consider here, so let's start by identifying what the question is asking us to do. So our goal is to find the driver's average speed for each of the 2 laps to the nearest mile per hour. So let's plan this out. What am I going to need to do in order to find these 2 different speeds? Well, I'm definitely going to have to know the average speed overall. Now, the information that we're given is that each lap is 2.5 miles and that a driver can complete 2 laps in 1.5 minutes. So, we need to set up a proportion to find out the average mile per hour of the driver. So let's think about it. If 1 lap is equal to 2.5 miles, how many miles are in 2 laps? The reason this is important is that the speed was given to us in terms of 2 laps. So if 2 laps takes 1.5 minutes, we can compare that to the distance of the 2 laps. Now, we want this all to be conducted in miles per hour. Okay, miles per minute doesn't help us so much. So it's also helpful to convert, if I know that 2 laps can be completed in 1.5 minutes, how many laps are completed in 60 minutes? And of course, keep in mind 1 hour, 60 minutes, use that to convert. So by using this information, you should be able to figure out the average mile per hour of the driver. From there, you know that on the second lap, the driver is 8 miles per hour faster. So consider what you know about averages. And then if I was looking at a number line, if I had an average right here, and I was averaging 2 numbers, it makes sense that one number must be lower than the average and one number must be higher than the average. It would be impossible to have an average where if I average 2 numbers, I get an average lower than both of them. That doesn't make sense, right? So keep in mind as you look through your answer choices that once you know the average mileage per hour, that means it definitely falls in between the 2 speeds of the driver taken on each lap. Question 2. A racing car driver makes a pit stop at the beginning of a lap. The time t in seconds that it takes the driver to complete the lap, including the pit stop, can be modeled by this equation. The variable r is the driver's average speed in miles per hour after the pit stop. What is the horizontal asymptote of the function? So we're given a lot of background information here, but notice that our question is simply what is the horizontal asymptote of this function. So we don't really need any of the information given to us to solve it. So consider this equation and think about how we solve for asymptotes. It's going to be helpful to separate the fraction into 2 different fractions. So this would be 12r over r plus 9,000 over r. Simplify and then think about what does the constant mean. So when you simplify both of these, you'll be left with an integer, and think about what it means when you have that integer on its own and how that helps you identify the horizontal asymptote of the function. Now, given our scenario in the last question, how many seconds did the driver spend at the pit stop? This is related to question 2. Think about what a pit stop means, and think about how that relates to what a horizontal asymptote is. Again, refer back to question 2 as you consider your answer for question 3. Question 4 says, the driver's average speed after the pit stop is 200 miles per hour. It takes the driver blank seconds to complete the lap, including the pit stop. Alright, well, we're given this equation, t time equals 12r plus 9,000r, and we were just given r, the average speed of the driver. So from here, if we're told that r is equal to 200, just plug in 200 and solve for t. Note that your time needs to be in seconds. Finally, question 5. In 1990, Ari set the record for the fastest Indy 500 average speed, about 186 miles per hour. The time in hours to finish the race based on his record can be modeled by a function t in terms of s, and that's what's given to us here, where s is the speed above 186 miles per hour. Evaluate the function for s equals 10. What does the value of this function represent? Okay, so there are two questions going on here. The first one just tells us to evaluate the function for s equals 10. So if I know s equals 10, I can plug 10 in right here and solve for t. So that's the first part of this. The second part of this is to consider what the value of this function represents. Now remember, this function t, time in terms of s, where s stands for the speed above 186 miles per hour. So consider that when answering the second part of this question.